Hello everyone and welcome to a new Ask Me Anything session with the Big Data Boutique. Today we are going to speak about usage patterns for Kafka. Different patterns for understand how we can use pattern also from architecture point of view. Just remember you have a chat on the right and you can write questions in any moment there and we will try to address them during the session or in the end. Okay, maybe here directly answering here or just directly writing in the chat depending on the question. So feel free to write there your questions or to send them by email, wherever it works for you. It's good for us, so just feel free to send your questions. What we are going to cover today is a couple of patterns, the observer pattern and the PubSub pattern, to understand a bit better Kafka from that perspective. And then we are going to see how to use the PubSub pattern in different use cases to take advantage of Kafka. The first thing is dual writes, how to avoid dual writes, how to have backpressure management thanks to Kafka. Then we are going to cover some interesting patterns when you are working with databases or data stores and you want to avoid coupling between different services. So we will cover CQRS, event sourcing, event collaboration. This just in the end, we will cover interesting uses called Outbox pattern using with CDC. And finally, well, you know, Kafka is just a tool. You can use it for very good things, but also you can use it wrongly. Okay, so we cover very briefly some Antipatterns we can see out there, just to try to prevent to use them. Okay, so let's start understanding observer versus PubSub pattern. Okay, well, observer is basically we have different services which are subscribed to a subject. When something changes in the subject, the observer receive a fire event telling them there was a change. The thing with the observer pattern is there is a strong coupling between the subject and the observer. Okay, because the subject needs to know about the observer. Okay, so it needs to know how to invoke the server to notify the different changes. Okay, so if we change the subject or if we change the server because we need to evolve it or for whatever other reason, we need to make aware the other part. Okay, so it's very coupled. Okay, that's not necessarily bad depending on what you want to do, and we have great examples of the server pattern. For example, if we see all the things that people are doing with reactive, when they are evolving the observer pattern to have a strong communication between the server and the subject, so they can negotiate things like the rate and other things. Okay, so if the observer is receiving too much information, we can notify to the subject, hey, please stop sending me so much information, so much data. Just slow down the rate, and I will notify again when I am ready to process more information at higher rates. Okay, so it's not something bad. Okay, it's not the PubSub is better than observer. That depending on your use cases, one can be better than another one. PubSub, what is the strong thing about PubSub is there is something in the middle, the event channel. And the event channel, basically, it's a very good abstraction to decouple the publisher and the subscriber. So the publisher doesn't need to know about the subscriber. He's just going to write messages to the event channel, and it can forget them because it's going to be sure the subscriber is going to receive the notifications. So it doesn't have to take into account the subscriber. And the same thing happened to the subscriber. It doesn't need to know about the publisher. It only knows about the event channel, how to receive information from the event channel. But if the publisher changes, it's not a big issue for the subscriber if the new publisher, the new version of the publisher is sending the same information. Okay, so we can evolve the publisher, we can scale it, we can make changes. We are not going to have to modify the subscriber, or if we have many subscribers, all of them. Okay. Kafka is a very good example of the pub-sub pattern, and that's one of the strong points of Kafka. Is exactly when we have many subscribers consuming the same information. So this is the typical case where Kafka is really, really good in comparison from other technologies like MQ and so on, where you can also do it, but Kafka for its architecture, it's better designed for that type of case. Okay. So this is the both differences between observer and both patterns. Okay, let's see both patterns in action to understand how we can use them. Okay, so typical case is dual writes. Okay, dual writes is a very simple concept. We have a web application. It may be a web application. It may be another service, whatever. Okay, but let's use a web application as an example. And this web application nowadays needs to write information to different stores. It needs to typically write information to a relational database, because relational databases are really good to organize information, keep the relations between all our entities. But it has also a cache, so it has to also write to the cache to maybe Redis or something like that to update or to validate records in the cache. And also it has to write in a document database or something like, for example, Elasticsearch, where you can easily then make search in that information. Okay, and it's really good, but you are going to have to put there, update the index, and so on. So this web application is writing all those databases. The thing is, if you do this with the observer pattern, where the web application is invoking each database sequentially or in parallel to write things, this can have several problems. Okay, for example, what happens if one database is not available? Okay, can we write to the other databases? Maybe we can, but there is some level of inconsistency between them, right? Or what happens if a database has too much load and is not able to process all the writes at the same rate than the other databases? What we have to do in that case, we have to go in the slower possible rate. And if we do that, it's not only that, it's our web application has to store the information locally until it's possible to store it in the database. So we need to have a lot of memory to make sure we are not going to lose data, and so on and so forth. Okay, so this is the typical concept of backpressure, where our application is generating information on a rate where our database is not able to process it and free our application to use the resources in other things, like give a good experience to the user using the web application. Okay, so this is generally a bad idea and something most of the time we should avoid. Okay, Kafka, the pub-sub pattern, it's a great example of how to avoid this type of things. Okay, so in our case, the web application is going to write in the log in Kafka. Okay, and it doesn't care anymore about what happens with that information. It's just in the log, it's safe, it's high available, it's replicated in different servers, so we are sure we're not going to lose it. And then each database at their own rate, it's able to retrieve that information and to persist it in their own storage. Okay, so they can consume at their own rate independently, and the web application can also go independent of the databases. So basically, we have a good level of abstraction and decoupling between the web application and the databases, and between them also. So that's a really better solution. If, for example, one database is really slow, it's not a problem. We are going to store the information in Kafka as much time as needed to give time to the database to process all the information and not lose any messages. Okay, so that's a very interesting use case for Kafka. It's heavily used out there. For example, it's very typical with Elasticsearch, where we put Kafka installation in front of the Elasticsearch, so we can write directly from Kafka and from Kafka to Elasticsearch, and we make sure Elasticsearch can handle whatever load is necessary. Okay, if we have a pico or whatever, it's not going to be a problem because we put it first in Kafka, and Kafka is really good, providing a very ingestion rate and also persisting information and making sure we are not going to lose it in any case. Well, another different pattern is CQRS. Okay, CQRS is some evolution of this pattern. So basically, what we have here, it's we separate our database in two different layers. We have the command model and the query model. So basically, when we receive information from our data, from our web application or whatever, we route that information through the command model. Okay, so we execute validations, logic, and whatever, and then we update the database. Okay, when we need to read, okay, we have the query model with different services interfaces. So we are accessing the database to read the information. Okay, and what is nice here is because we are not directly writing to the database, but basically what we can do is adapt our information or our data model in the database to the query model, because it's the couplet of the writing model. Okay, so basically in the command model, for example, we can generate in the database different views for different optimized for different queries in our service interface, and providing that information adapted to our web application. Okay, so this is a good optimization in some cases. It's not always a good pattern. That depends on the complexity of your application mainly. So if you, for example, it's a crude application where you basically are doing create, update, delete, and read records, probably CQRS is not a good approach, because it's going to introduce a big level of complexity in your application, but it's not going to give you too much advantage because the command model is going to be just directly stored in the database, and the services is going to just read. You don't need to do any processing or taking advantage of that. Okay, but if you have very complex queries and you need to provide very complex services, aggregations, and so on, in that particular case, this could be a good model. So basically, what you are doing in the command model, it's you're pre-processing that information, generating those views in the database. So when the query model doesn't have to do in real time those aggregations or complex joins between tables or whatever, because you have done that in the common model previously and you have stored the result in the database. So the queries is going to be a lot simpler, and in general terms the interface is going to be a lot more performant than a normal CRUD architecture. Okay, so this is a possibility, this is an option, it's not the only one. As always, it has advantages and disadvantages depending on what you want to do. Okay, Kafka is a good way to implement this pattern. So you put Kafka in the middle, and you use some streaming framework like Kafka Streams or Flink, so you can just easily process the information, receive it from the web application, which is going to put the information in Kafka. Then you process that information with the framework. You generate in the database the records as you are going to need to read them later directly from the web application. So that's an interesting way to optimize web applications and databases, and to make databases more performant, specifically when we are working with NoSQL databases, where it's very important to organize information in a way the service interface is able to read it easily. Okay, with that you just can prepare information in early in the flow to make sure it's ready when it needs to be read. Another pattern which is built in top of the CQRS pattern, it's a specialization of that pattern, is event sourcing. Okay, event sourcing, it's basically we have this write interface we speak before. We put that information in Kafka, and then which is the event store in this case. Okay, and then using, in this case, Kafka Streams, but wherever other, we read that information and we process that information in a way we have the state of our application. So, for example, if we are receiving an update of a record, what we do is have that record. We already have that record in our state store. So we update our record and we keep that record in our state store updated, and we just drop the message. We don't store all the information. Okay, we don't need to in our state store to have all the information generated by the application. Only the information which is needed to be read by the reader interface. Okay, so for that, Kafka Streams or Flink or even Spark Studio Streaming have very good support for state storage. Basically, what we do here is we keep in memory all that information. It's like a key value database we have in memory, and we can distribute between different servers, and that gives us very, very quick access to information. Okay, so for example, we can use this as a cache in where we have some information in memory updated in real time with whatever is happening in the application, and because it's in memory, it's going to be really easy to be read by the reader interface. Okay, so the latency to consult that information is going to be very, very low. And at the same time, we can also proceed that information from the Kafka topic to a long-term database or a relational database or other things. Okay, that's perfectly possible. One of the examples of using this is don't have a long-term database at all. Wherever we need to rebuild the state store, we read directly from the Kafka topic. So we start the information from the Kafka topic in the Kafka topic from the very beginning, and we rebuild from the very beginning the state store. So if we have in the history record has been updated several times, what we do is to reprocess all those updates to generate the final version of that specific record. That's quite consuming, and it can be very slow depending of how many records you have and how many updates and so on. What it provides Kafka to do things like that is compactation. So basically, you can tell Kafka the other versions of that record, just drop them and keep in the topic only the new one. So it's a process launched periodically, which is able to do all that cleaning in your Kafka topic to avoid to have a too big topic and to have information which is needed, which is not useful anymore. Okay, be aware, compactation it's a good thing. It's a good way to save space in your Kafka installation, but don't use compactation for business use case. I see that in some projects where people want to avoid the duplicates, for example, and they think, okay, because with compactation in some point the old records are going to disappear, and so we are going to avoid duplicates. It's not the case. Compactation is not about avoid duplicates. It's about to save space. So don't use compactation for things like that, because in the long term you're going to face a lot of problems. So there are other ways you can do that. You can do that with tables in Kafka streams. You can have other ways to avoid duplicates, but compactation is just not the right way. Well, we have another one. This is again based in event sourcing. So basically, what we are doing here is we are evolving from CQRS to event sourcing to event collaboration. That's the same path I see in many companies. They start implementing CQRS to have some performance improvements in the databases. Then they move to event sourcing, basically to decouple systems and to avoid them to be coupled between them. And then once they're familiar with that and they see the advantages, they start with event collaboration pattern. Basically, with event collaboration pattern, what we do as a microservice, as a specific service, is we write in Kafka each time we change our state. So when something happens in our system, we write it in Kafka, and we let others to process that information. So basically, what we can do, the other systems is, okay, something has changed in system A. So I can have a replica of the state of system A, because I can read when that system changes, I can read the change. I can apply event sourcing, so I can build a specific view of the state of that system. So when I need to request information from that system, instead of go synchronously to that system to ask for the information, I can just go to my local copy, to my state store, where I have the view of that system. The nice thing about this pattern is when that happens, if my system A fails for whatever reason, or it's not available, the other systems are not going to be affected, because they have a local copy with the information they need in their own state store. Okay, so that's the powerful thing about event collaboration pattern. It's allow to decouple systems and to make systems independent of others. So for example, in microservices architectures, where typically microservices are strongly connected, you can use this type of pattern to make sure if a specific microservice have problems, it doesn't affect the others because they have a local copy of the state of that of the service microservice with problems. So it's an interesting way to improve the reliability of your systems. Okay, we are seeing a lot of companies now using event collaboration pattern and changing also the mindset from other systems request information from me to this pattern where I just don't give information, I just publish my changes in a topic and I let the other systems build the information they want to use. It's also very useful to avoid ETLs and things like that because with that it's just you don't need a batch process copying information from one place to another one. That's happening in real time. Each time the system changes, publish the change in Kafka. So if you have replicas of the information in other places, you can just read from Kafka and apply that change in the different replicas, and eventually they are going to evolve to have the same information. So it's a most performant way to replicate information in your organization than the typical ETL batch process we are used to do in many organizations. Has many problems when you need to scale or when it's a very big organization. Well, let's cover the O-box pattern. That's interesting pattern. It's quite new. Well, this pattern is about build event collaboration pattern, for example, for the order service, where the order service want to publish the changes. And you want to publish the changes in different topics, for example, in order events. Okay, so if the order service is not able to publish directly in Kafka, and there are several reasons for that. Maybe the messages are not compliant with Kafka. Maybe it's using an old version of Java and there are not available libraries. Maybe it's a legacy system and just you are not confident enough to make changes on them. Okay, if that's type of things is happening to you, what you can do is to use change data capture, which is basically monitor the database where your other service is writing. With CDC, you are able to retrieve the changes directly in a specific table in the database. There are several ways to do that. One of the open source projects to do that is Debezium, which is able to read from MySQL, from Postgre, from Oracle, from IBM, from Mongo. So basically, each time the table order change is going to generate a new record in Kafka. So the shipment service or the customer service can receive that information and to process it. Okay. The problem with CDC is because you are doing this in database level, even if it's quite performant, the information is quite complicated to understand. It's just not an event. The order service and the shipment service have agreed to communicate. They are going just to receive how a database change, okay, a database table change, and that's quite low level information. It's not always easy to be interpreted for external system. So the outbox pattern, the idea is have a specific table, the outbox table, where the order service writes with the idea of is going to be consumed from other services and publish it to Kafka. Okay, so just it's not the normal table, it's just another with a structure, make it more suitable to be published in Kafka using CDC. Okay, the good thing, it's like a mid-term between have something like event collaboration and your normal record. So the point here is your older service maybe cannot publish directly to Kafka, but it can already write to the database. So you just need to create a new table with the specific format and adapt the other service to write in that table. Okay, this is a change in the other service. It's not so powerful as CDC as we initially see it, but it's usually easy for a system just to modify their storage, the database, to just add a new table and write to it. Okay, because you already have the connection, you are doing it for other tables, and it shouldn't be a so big change. Obviously, depend of the service, but it's something in the middle. It's interesting for the cases where you cannot publish directly to Kafka. Well, finally, we have reviewed several good patterns, but I would like also to speak about anti-patterns, because Kafka is not a silver bullet. You can use it for very interesting things, but you can also use it broadly. It was very interesting, this technology radar, where they were specifically speaking about some anti-patterns with Kafka, which is basically recreate the typical enterprise service bus patterns, but changing the middleware, the MQ or whatever middleware you're using for your enterprise service bus for Kafka, and don't taking account the specific things in Kafka, or where Kafka is strong and when it isn't. Okay, so this is an anti-pattern. There are some cases where Kafka is really good, but there are others where MQ it's better, and also it's a big problem where you try to build many layers in top of Kafka, because it has Kafka is a quite complex service. If you build a lot of layers on top of it, it's, you're going to build something quite complex in the end, and hard to, maybe easy to use, but really hard to maintain. So you need to be aware of that, and don't try to use the same things, the same layer architecture, layer over layer architecture with Kafka. It's, in my experience, a lot better if you try to provide Kafka as a service, but not creating many frameworks on top of it, or a very complex solution on top of it, or your own customization of Kafka. Okay, that's not work in the long term, because it's really expensive to maintain, and in general terms is going to be something problematic for you in the future. So just try to avoid that. Try to keep things simple. Try to use the right tool for the right thing, and don't try to use Kafka as any other messaging platform. Just understand where Kafka is strong, when it isn't, and use it properly. The main reason for this pattern is many companies which were using enterprise service bus, the team in charge of that starts with Kafka. So they know about the service bus, and now they're working with Kafka, and they do it in the same way because that's what they know. Okay, but it's just problematic in the end. So it's better if you have some Kafka expert who can guide you initially, who can explain to that team what are the differences, how Kafka should be used, and that in the end it's going to be a lot better for you. Okay, so that's all let's wait for questions. Just remember, you can send them by email. You can also write in the chat. There is some latency, so if I don't answer them directly here, I will write the answer in the chat. Don't worry about it, okay? So let me check. Okay, we have one question in the mail. Specifically, it's about the collaboration pattern. What is the main challenge for organizations to use this pattern? Okay, that's an excellent question. What the problem with collaboration pattern most of the time is change your mindset and combines the teams to stop providing synchronous APIs to start just publishing their own information in Kafka and letting them others to consume that information. If you're not used to that, it's a bit scary for most of the teams because they start to think, hey, how the other teams are going to use my data and why. And what happens if I change my state and I stop publishing my data in the same way, or I start doing it in a different way? And that they are very good questions indeed. Okay, so you really need to have an answer for them. For example, typically you need to have some type of coordination because in the end, when you do that, you have an interface agreement with your consumers. So for me, it's very, very interesting if you are embracing this type of pattern to have some kind of API first strategy into your organization, not only for REST APIs, but also for asynchronous APIs, where the teams can see how the events are evolving, how they're changing, how they can discuss what they need, what they don't need, and there are, in general, is just have a good communications with teams, making sure they work together to publish or consume that information. The other thing is you are publishing information, but you don't know who is using it or for what. Okay, so to avoid that and to give more security to the teams, what I like to do is have some type of self-service. So basically, you have a tool where you can list all the topics available in your organization, and you can request access to them. So the producer or the service, which is owner of that specific topic, for example, the order service we see initially, is going to say, okay, this other service wants to consume my information. That's fine. I'm going to allow it, and that service has control of who is using that information. And the nice thing about that is, in some point, you need to change the contract with them. You have, using this self-service application, you have direct access to them, so you can generate a new version in a different topic and notify them, hey, we have a new version, just please in the next 3 months try to stop consuming from the other version and just migrate to the new one, or wherever it makes sense for your case. I mean, there are several approaches to do that, but the thing is, you have a way to identify them, to contact them, and even to change how they consume from your topics. And that's a very good approach to make all these event collaboration pattern easier to implement in big organizations. Okay, yeah, I have another question asking about the Antipatterns. What are the most typical Antipatterns you can see? Yeah, well, for me, it's the typical things where I see the most common Antipatterns I see is try to use Kafka as an MQ. One great examples of that is when teams need ordering, for example, or need exactly one semantics. That's possible in Kafka. It's possible. The Kafka has evolved to have those things, but in the end of the day, it was not designed to have those things initially, and that and there are other services like MQs which have been designed from the very beginning, thinking in intersections, and most of the time they are more mature and better suited when you need just to have transactional integration between two different services. And that's not, you can do that with Kafka, yes, you can, but typically MQ is going to give you better guarantees on that. The thing is, when you have more than one consumer, for example, then Kafka is great. Or if you need to replay events, so you need the broker to store information for a period of time, or basically in different criteria, and not just to delete it when it's ready for the consumer, then Kafka is great. But that's not always the case in many organizations. Sometimes when I speak with other architects and they start to design the solution on top of Kafka, and you see, okay, this is going just too complex, and it shouldn't be so complex. And probably it's because we are just trying to use Kafka in a use case Kafka is not suitable for. You can use it, yes, and if Kafka is the only thing you have, that's fine, let's go with Kafka. But that's not the case for most of the big organizations out there, where you have several options, and it's just to choose the best option for you. That's one of the Antipatterns. The another one I see, it's while Kafka is quite interesting tool, because many other applications now provide some type of out-of-the-box integration with Kafka. So if you need to consume from Kafka using Spark, that's just perfectly fine. If you do want to do it with Flink, it's perfectly fine. There are many applications out there which provide some type of configuration where you publish your Kafka connection details, and they just publish the information directly to Kafka, so you can then consume it anywhere. So all that type of things make Kafka very powerful, because you can have Kafka in your organization and you use it to integrate and to easily connect different pieces. But some organizations think in Kafka like this integration layer, and they start to build frameworks and another custom layers for your organization to have things like specific authentication, or specific authorization, or you just create a model of your message which has to be respected for all the people using Kafka in your organization. And that seems interesting, good in the beginning, because it's like this, if we don't do this is going to be a mess. But in the end, what you're doing is restricting how Kafka is used in your application, and that's a problem for many people. It's going to make Kafka harder to use in the organization, and then people is going to start looking for other solutions out of Kafka. So when you are the Kafka architect in the organization, just take that in mind. It's just not make things too complicated. Try to open Kafka to everybody in your organization. Try to make it as much out of the box as possible. Don't try to reinvent the wheel. Don't try to reuse specific libraries or custom libraries and things like that. It's almost everything is invented right now in the Kafka ecosystem. It's evolving very fast. So if you build your own solution, maintain it and keep it updated with the last Kafka versions is going to be really expensive. So make things simpler, focus in government, in self-service, focus in API first for your asynchronous events and so on, but don't try to build another framework on top of Kafka. Okay, it's almost always a bad idea. It's also true there are options here because and something I recommend to many organizations is don't have just one cluster or one Kafka installation, because Kafka is used for different areas for different things. Typically what I see is there are areas using it, for example, for logging and tracing. There are other areas using it for analytics and database integration, CDC, and so on. And there are other ones using it as a integration bus in the organization for example, microservices. And so on. So don't try to use the same Kafka for everything. Just split it in different clusters, the governance of them, make it different, adapted to the specific use case of those installations, and just iterate over that in a different way, making sure it's used. In the end, Kafka, it's a very specific piece, so it doesn't make too much sense to have to try to standardize Kafka in an organization, as you are not going to standardize Java or Scala. It's going to be used differently for different teams, so you can provide some guidance, you can provide some guidelines, but don't you can tell to everyone to use or to use it exactly in the same way, because you have to adapt it to the requirements and to the business needs of each case. Okay, so that, I think that's the main anti-pattern I see out there. Okay, we are running out of time, so I'm going to stop here today, but if I will keep the string open for a while. If you have any question more, please just write it in the chat and I will be happy to answer it. So thank you very much. I will see you in the next session. Thank you.